Hi everyone, welcome or welcome back to my channel. In today's video, we are going to solve a question that is based on binary search, and the question is painter's partition. So first let's see what question says. So you are given A painters and an array C of n integers, where Ci is denoting the length of ith board. Okay, and each painter is taking B units of time to paint 1 unit of board. Okay, so first let's see in some pictorial format. So it says that we have been given these three values where A means the number of painters. Okay, let's start from C first of all. So C is basically an array which we will be given here. For example, this one where each element of the array is denoting the length of each board inside it. For example, we have, let's say, two board in the array, means C is representing the boards basically, and the elements are representing the length of each board. So let's say we have here two board. The first one is of length 1 unit, the second one is of length 10 units. Then B means it's time taken to paint each board. For example, time taken to paint each unit length of the board. Okay, so for example, we have the board which has the 1 unit length. So time taken to paint that board is going to be 5 into 1, that's 5. Then second board which has unit length of 10. So the time taken to paint the second board is going to be 5 into 10, that's 50. And total number of painters which we have been given 2. We have to, let me just read the question further. It says that you must assign the boards to painters in such a way. So we have been given the number of painters as certain constraints. So we have to assign the painters to paint these boards. Okay, and we also have to find out the minimum time within which they can paint them, given the conditions. That first is that each painter paint only the contiguous segments of the boards. It's not like the first painter is painting the first board, then again the third one. They have to paint it continuously. Then second condition is that there should be no board which could be split between the painters. It's not like that first part is done by one painter or another one is done by another painter. The third condition is that we have to minimize the time to paint all board, and at the end the minimized value we have to return in the form of modulus. Now whenever we have to minimize or maximize something, we can always think about binary search, right? So let's see how can we do this. So I explained the question right now. So we have the term around which we have to basically think our solution is, that's time. We need to optimize time in this question. So what would be the possible, maximum possible time or the minimum possible time? Means that range I'm talking about, which you can think that okay, my answer is going to lie between this range only. It can't go beyond them. So we can think about two scenarios. First is the best possible scenario, another one is the worst possible scenario. So in this criteria, what could be the best possible scenario? Means we could consider it as ki minimum itna time to we have to give to the painters. So the best possible scenario could be that suppose we have unlimited number of painters. We don't have to even see this count. So still हमें इतना time लगेगा ही लगेगा. So how can we determine that? We can think that okay, among these boards we have this first, the at first index, the board with 10 units of length. This is the maximum size of board. Okay, so इसको पेंट करने में जो टाइम लगेगा, that is going to be कि like इतना तो लगना ही लगना है for sure. So at least we can say that we are going to take 10 into 5, it means 50 units of time, right? So we can say कि minimum time is going to be 50. Now what could be the maximum time? That is the worst case scenario. Now suppose we have been given only one painter to paint the entire, range of boards. So he has to paint all the board. It means total time required by that one painter is going to be summation of the time required to paint all the boards. It means 1 into 5 plus 10 into 5. That's going to be 55. Okay. Now, we can say this very confidently that our answer is going to lie between these two numbers only. Okay, so we can form here this range that our answer is going to lie between 50 and 55. It's not going to lie beyond these two numbers. We'll check it how we are going to find out that whether this number is possible or not. So while doing it with binary search, we can anyways find the mid element, and then we can iterate through the array, and then we can solve it. But right now I'm going to assume certain number between them. So right now I've taken the number 53. 53 means each painter, we have given a limit to them, that they have been allotted the time of 53 unit of time, whatever it is, it's minute or whatever. Now we have been given this time, and we'll check that how many painters are we requiring to paint the two boards given this constraint. And if we notice that okay, we are requiring two painters, or you can say less than them, it means it's a possible scenario. It could be painted. So let's go for some lower lower assumed value. It means if 53 is a possible scenario, we'll check for 52. If 52 is possible, we'll check for 51. Gradually we'll decrease the value till 50. So I'm going to do the dry run for this number, and then we'll go to the code. So we have given the value of A over here, means we have been given two painters. So first, let's say we'll forget about it for now because we are not calculating that how many painters we require. Okay. So suppose we have taken the very first painter. Okay. It will go to the first board. What will be the current? Now current time initially will be 0. Okay. Total time will also be 0. Current time is actually talking about the painter who is painting the current board. So what is the current time taken by that? And total time is something which we are accumulating for a single painter. Okay. So the first painter went to the first board. So what time is it is going to take in order to paint it? So time will be 5 into 1, because 5 is the time taken to paint each unit of length, and total length is 1. So 5 unit of time will be taken by it. The first we will check that is the time taken by the first painter, that's the current time, is it less than the time which we have assumed? If it is less than that, then it's okay, we can add it to the total time. If it's not, then we can return false because it's not possible. So we'll add it to the current time, and then we'll check that is the total time that we have basically total time taken by the first painter right now, that plus current time. If that is lying between this mid value only, then we are going to add it to it. Otherwise we'll take another painter. So it's less than it. 0 plus 5 is less than 53, so we are going to add it to this. Okay. Now again we'll check for the second basically board. Okay. So we'll see that the first painter is going to paint this or not. So time will be 5 into 10. That's going to be 50. So we'll first check, okay, means current time is 50 right now. So we'll check ki is 50 less than the assumed time value? It's less than that, so we won't return false. Now we'll check that is 50 plus total time, that is current time plus total time. Is it lying between the assumed value? It's not lying between the assumed value. So what we are going to do, we'll say that okay, for first painter the task is over. So we are going to assign the second board to a new painter. So we'll say that we need here one more painter. Additionally, one more painter we need in order to paint the second board. And then what we'll do here, we'll update our total time with the current time. That's going to be 50. Okay. So now we'll check. Now we're going to see that all the boards are painted. We have reached to the end of the array, and the total number of painters which we required was that is 2, which is less than equal to A. That is the total painter which was allotted to us. So it means this is a possible scenario. So we can explore to the lesser value. Now, while doing that, we'll notice that our output is going to be 50. It means at 50, we are going to get our optimal time. Means that is the optimal time at which two painters can paint the entire board. So let's go to the code. So in the code, we are going to follow the same approach the way we have done in the dry run. So first of all, we'll declare the start and the end, which was the range between which we assumed our answer to lie. Okay. So how we declared it? For start, we said that it's going to be the maximum length of the board into the time taken. So, and we'll be using the long data type here so that it could prevent this from TLE. Start is equals to maximum element of C dot begin, comma C dot end. That's going to become the maximum length, and then we'll multiply it by B. That's the total time taken. Then how did we decide our end value? So end was basically we assume that let's say we have only one painter, then that painter has to paint each and every board, right? So total time taken by that painter will be summation of length of all the boards into the total time taken. So here I'll be just I'll use accumulate function. Comma 0 into B. Okay. And we can also use your long because TL might come. That's why. Now we are going to apply our binary search. Now this is where we were basically assuming the things there, but right now we'll use proper binary search. So while our start is less than equals to E, first we'll calculate our mid at this point. It's going to be S plus E minus S by 2. Now this is our assumed value that we assumed in the dry run, but here we have the mid. So we'll check that if the function will be there. Now it means if our assumption is correct, if the mid is the correct answer, it means explore for the smaller values. Otherwise, if it's not, then you can go for the bigger values. Because we have to, search for minimum possible value, right? That's why. And at the end we can return our smallest. Basically, why we're returning the smallest value? Because it says that it's the first valid answer, that's why. So we'll return, because whenever this loop will come out now, like whenever the condition will be like S is greater than E, then the S is going to be our first possible answer. That's why we'll return S. Return, and we'll also convert it into int, typecast it S. What was the value given here? Okay. Now we have returned our answer, but first we have to write this function. So let the function be isPossible, and the parameters I'll put as A, then B, and then C will be there. Okay. And then mid. Okay, so if this is correct, it means the arrangement, the possibility, the assumption was correct. We'll go for the smaller values, otherwise we'll go for the bigger values, right? Okay, now let me write down this function. Bool isPossible. Now here comes the logic which we were doing there, right? So let me show you all how we were doing in the dry run. It's not Yeah. Okay. So how we were checking it, we took two variables. First is our current time. Second one is going to be our total time. Okay. So current time is going to tell us that currently the painter which is painting a particular board, how much time is taken by it. We're talking here about only that board. That is going to be our current time. Okay, and that is going to be accumulated into our total time until and unless the total time exceeds our assumed value. That's the mid in this case. And if it's exceeding the mid, then we are going to increment the number of painters. So this is how we are going to calculate the number of time. I mean the total time which we are requiring here. And then we'll also calculate the painters, number of painters required. So initially what we did by default, the number of painters, that was 1 because we are taking one painter by default here. Then total time was initialized with 0. Total time is equals to 0. Then we are going to basically traverse across the entire array. So for int I is equals to 0, I less than c dot size. Now here we are going to declare our current time, because current time is talking only about a particular board painted by a particular painter. That's it. Here also long current time, that's equals to. Now current time is what? Here also we can see it is value of c that at this index into I. So and that's also typecasted into long. So that's ci into b. Okay. Then we were checking here, right? After calculating the current time, you remember we were checking here if it is greater than mid, it means then and there you can return false. So that condition I'll write here. If our current time, if that is going to exceed our mid, then we can return false. Otherwise, we can proceed with our further implementation. So then what we'll do, we'll decide if we can add this current time inside our total time or not. So we'll do the similar thing. We'll check that if total time plus current time, which we have calculated right now, if that is less than equals to mid, then we can proceed adding both of them, right? We can do here total time plus equals to current time. Otherwise, if it's greater than mid, if it's crossing the limit which we have taken, then else. First of all, we are going to increase the count of painter. It was painter, yeah. First of all, we are going to increase the counter of painter. Then we'll also update our total time with current time. Why we are doing so? Because the total time, the value inside the total time which we have before, that is already assigned to the first painter. From the second painter we have to do a fresh start in all the things in order to when it comes to time or uh, what was that board, everything. So that's a fresh start for the second painter. So total time is equals to current time. Now after counting the number of painters and all, we'll just check that if the number of painters which was required to paint all the board in this time limit, if that is coming out to be less than equals to a or not. If yes, it means our possibility, our assumption was correct. We can go for the lesser value. If not, then we have to go for the higher values. So let's try to submit this. I think error might come because okay. Yeah. Okay, so test cases are passing. So first, let's see what could be the space and time complexity here. So for space, we're not using any extra space in this question. So space complexity is going to be constant, that is bigger of 1. For time complexity, we can see that first of all, we are traversing through this array, that is C, and we're also using a binary search whose range is lying between this. That is the maximum value of the array into into B, and then the accumulation into B. So I think it could be bigger of n into this accumulated value. I think so. So that's going to be T is equals to big of n log s, where s is going to be the summation of entire array, and space complexity is going to be big of 1. So this was all about it. Thank you for watching.